Hi, welcome to howtostats.com. In this video I'm going to demonstrate how to perform an analysis of covariance, or ANCOVA, in SPSS. Now ANCOVA is a interesting statistic, and I think it's one that a lot of people have a bit of trouble understanding, both conceptually as well as performing it in SPSS. So that makes it interesting in that it's a relatively sophisticated statistical technique. Now I've tried to keep it very simple in this case, or relatively simple, in terms of the design of these are actually real data. It's not an experiment. It's actually a study where the hypothesis was that males had a larger cranial capacity than females. So that was the first hypothesis. But then the secondary issue was that although males may have a larger cranial capacity than females, that may simply be due to the fact that they have larger body sizes in general. And so the statistical problem here to solve is to try to control for the fact that males have larger body sizes, yes, but once you control for that, do males still have larger cranial capacities than females? And this is the type of analysis that would be particularly suitable for, arguably, an analysis of covariance, because we want to test the difference between two means. In this case, there are only two, male and female. In an analysis of covariance, you can have more than two means. You can have 3, 4, 5. But in this case, it's simple. It's only two means. So we want to know the difference between males and females in cranial capacity, but controlling for the fact that there are differences in body size. So to perform this analysis, there are two steps to doing this procedurally. And the reason for that is that you first want to test a serious assumption in ANCOVA, which is the homogeneity of regression assumption. And basically that means that the covariate has an equal regression coefficient associated with both groups. In this case, there are only two. If it were a multi-level, more than two levels of the independent variable, then you would assume that the regression coefficient is the same across all the groups, not just two. Now, what I'm going to do first is I'm going to test just a plain ordinary analysis of variance to see if there are differences between the means in cranial capacity between males and females. I'm not going to take into consideration body size. So let's just see if they differ, period. So we'll go into general linear model. Now you can do an ANOVA in compare means, but you can't do an analysis of covariance in this option. In order to do the analysis of covariance, you have to go into analyze general linear model univariate, and let me just take those out, because I've done this analysis already. So this is what you'd have, and in my case this is the independent variable, cranial capacity is the dependent variable, and then I've got my three indicators of body size, and I'm going to deal with those later. So in the first instance, I just want to see, do males and females differ in cranial capacity, independent, not considering any other issues. Okay, so I want to look at my means for sex, and I've got effect size checked and homogeneity of variance test. This is not going to test the assumption of homogeneity of regression. This is only going to be homogeneity of variance, just like in the plain ordinary ANOVA. A unit model has been, let me check that. Oh yes, should have that in full factorial. Sorry, that would just be the default, would be full factorial. Because I've done this analysis several times, just checking things out, there are some options here. So when you do the model, make sure that's full factorial, and then click continue. That's the default anyway. So I'm going to click on, I'm going to be changing that later. So what we have here are females. There's a number of 60 of them, males 40. And I have to say that that's actually a little bit of a complication in this type of analysis, to have unequal sample sizes. I'm not going to deal with that today. It's a relatively complicated issue. So I'm not going to really talk about the sums of square differences that you might use to accommodate for that. So females have a cranial capacity of 1,270 cubic centimeters, and males have 1,000